Good evening, everyone. Our project is IoT and Sensor Array Networking. My name is Corinne, and me and my group are going to present and demonstrate both on the project of IoT and Sensor Array Networking. So this is our project client details. Client name is Dick Hedford, company name is Allright, and our supervisor is Miss Nandini, Sidnal. Okay, so this is our project overview. I am going to explain the overview of our whole project. So the first one is IoT and sensor networking, IoT enabled business, that we are going to use the sensor from the farm to the market, and sensor are going to attach with the products, and product will have their own product ID. And sensor is going to sense the data from all the food supply chain, and they are going to send the data to the database storage system. And it will be a real-time food analysis for quality and ingredients. Means the sensor will sense the data, that will be a real-time. And the user-friendly system for food analysis. For the customers, the whole system will be user-friendly, so they can understand better how to analyze, because the requirement of our client is DIY, means do-it-yourself food assessment, live tracking of foods from farm to store. And our client requirements is end-to-end food tracking system, data visualizations, data analytics with statistical approach. It means that when sensor will sense the data, and finally it will come to the customer, that customer will get the result in the form of graph. So what is the product growth, and what is how much data is sensing the sensor, different sensors. Customer interaction with food and quality analysis without any third-party interaction. It means the do-it-yourself food assessment is the very innovative part of our client, that a customer doesn't have to take any help from others, and they can do it by self analysis of food. Customer-centric approach to provide healthy data about food and quality. The whole data will get to their app about the about the food and quality. And next, the project design is explained by Anuja.
Project design, businesses with multiple sensors with multiple locations, which means that all the product will have their particular sensors, and the same sensor will be used from the farm to the market till it's sold. Sensor details with different category in different business, which means that the sensor data will be used from the very beginning, and that will be there till the end. Business product with unique label ID, which means each product will have a very unique ID from very beginning till its end, and it will not be used in any other products. Sensor product data collection with different attributes, which means that each product has its different attribute tables, that is product ID, its order ID, and assessment ID. And when we get the information from the product, all the information would be grouped in different attributes IDs, and this be product-based analytics, which means that since we're doing it manually because we don't have a sensor, the company will be doing it in a very real-time sensor, and it will be displayed in the dashboard in the form of graph. Next slide. No,
Hi everyone. I'm gonna be explain how the whole process is working. I can use the SQL Yoke. I can use the GenMap. I can connect the NetBeans as a web-based application ID. I can show how whole the project is work. We using the Maven tools for the all Java is used for the interactive development with our service is here. I can show you our service ID is Apache Tomiko 8.0.27.0. I load all the Java system into the NetBeans, and I can run this system as manually. If I put on the run, it's gonna be automatically go onto the Google Chrome, and there is a one display show is with the user ID and password. Yep, is connecting with the localhost 8084/B2B platform, which I put into the programming language, and then I can put my master admin is my username. I can put my password over there, then it comes up to to me login into that. When I can log in into this local host, you can see there is a 5 different options. This is my application for the laptops. I can generate for the food assessment. I can provide one local host. What is the use of the local host is that local host fetch all the data from all the sensors directly, and it automatically comes up into the database. So we do not want to put all the data from the outside. It's automatically fetch up from the sensors, and all the database generated automatically. And we can use the JSON format for that. So JSON format going to be put all the data into the step-by-step manner, like a product ID, color, code, and what the height, temperature, and something like that. I can show you how this application is work. And one more important point about this application is this is the user-friendly and also the business-friendly application. So no one can spend more money for that. The businessman also use this application, and the user also use this application. I can put like a 5 format over there. One is dashboard, one is settings. There is a main business over there. One main business is the master business. In that I can put like FSC business is like a subcontractor for the master business. Is like one is master admin. I can put my admin in there. There is a one business of mine. If Farin wants to put his business, he want to just create here and create the new business, and it's gonna become up over there. So we kind of put everyone's business over there. And what is the outcome of this application is, in my business, there is a different data I have. I can show you how come it's work. I can select my FSC business. I can put 3 sensors manually in there. Right now there is a 3 sensors. I can put their locations. We can put like what sensors doing, like they sense like their color, their quality, where they're located, when they grown, and when they expired as well. And one sensor is also sense how the product quality goes up day by day. If I select the first sensor, double click, it's going to become up on the left hand side like a sensor business name, sensor's name. There is a description of the sensor is sensor 1, sensor type is C3, location is Adelaide, status, sensor latitude and sensor longitude. I can inspect this data with the inspect screen. You have to see over there. Then I can go to the network. I can update all these sensor details into the network. It comes up over on the inspect screen, and I can save it. When just I click on the save screen, there is a you can see the request URL. This is my local host system. This system is used to fetch all the data from the sensor. All the data from the sensor is directly fetched for this local host system. So if there is a data format is you can see there is a business company ID 7, sensor name is sensor 1, sensor disk is this is a first sensor, description is sensor type is C3, sensor location Adelaide, sensor status 1, and all the longitudes and ID. When you want to see the source from the sensor is in this format, we're gonna be show you. Now I move into the generals. I can put the blank for that because I generate the user ID and password for the user access for the general. So there is a one unique user ID and password which comes from the company. When you log in on the Allrip website as a guest, they give you the mail as a user ID and password. That user ID and password is unique ID and password. Then you can enter the details over there and just similar login as the business ID. And there is a one screen show up the user ID and barcodes. Then you have to scan just barcode on the sticker on the fruit, whichever you buy from the Woolworth, Wholesale, or any of fruit market or anywhere else. And then after, we're gonna go to the personal. If you want to change the password of your business module, you can change. If you want to change your password, your user module, you also want to change. And my future system is something like that. I'm going to create one automatic fetching system. I'm not going to interrupt into the directly business, but I'm going to create one final prototype which fetch the data from the sensors, and that data all comes into the database, and then after we're gonna be see how the fruit is grown up and by the analytical graphs and the pie system. So this pie chart shows like this is the sensor 1, 2, 3, 4, 5, 6. Not every sensor sends the same data. Each sensor have their own capability to sense the data. So sensor 1 sends the small data, sensor 3 sends the more data like the temperature, humidity and everything they sense. So they're gonna be stored into the database directly. That's why I put the local host for that. Now I can going to give you the Saqib to explain the next slide.
Quickly.
Design approach, we've used Java as our language for the whole system. Service layer architecture to communicate between sensor and the server, as you could see in the demonstration. It's very simple and user-friendly, and clean data input strategy, which means that every data we get gets into the required attribute, and it couldn't be mixed up or jumbled up. And automatic data collection from sensor, if it was a real time, because we are using manual, so when it's real time, the automatic data collection will be collected from the sensor and put into the system, and you can visualize in the dashboard in the form of graphs. The next will be done by Saqib.
Thank you, Manju.
Yeah, good evening, everyone. As my partner here already described this part as the result on our demonstration part. So here, this is the pie chart. It's related to all the sensors. We used almost 6 sensors, and the statistics over there. And the dashboard is this is the dashboard. So for for the real-time system and also for the business analytics. For business and sender management, and the sender products manages business products and their mapping with the sensor for real-time data collection. It means like for any fruit like apple, they need to take the data for apple. We need to make sure that it goes to the data table for the apple one. It not goes to the mango or not for the banana. So it's like that. Yeah, for the comparative analysis, business with sensor and modularized evaluation process for the sensor data from the backend system, automatic data interaction and collection between the system and the sensors with business server and the business products. The server, the sensors we have used, it needs to put the data on the server, and also the products, they will also collect the data. And for the data visualization for dashboard and the products, we have already showed in our. And for the limitation and conclusion, Praveen will.
Yeah, this is a automatic, and this automatic scanning product ID from sensor will detect every product ID and will store in the database, and it is a manual entry when the product will come out, and it will enter to the manually enter to the database. And the real-time formula for the calculating the food quality is to the growth of the fruit, like apple and everything. He will justify it about for temperature and what is the growth of the fruit, and yeah, this is all about this.